All right, here we are again. Course 2, Lesson 62, all about classifying triangles. Now, we already know about angles. We already should know about angles, so I'm going to just review. All right, so look here. This kind of angle be a right angle. This angle, because it's 90 degrees. This angle is less than 90 degrees, so it's an acute angle. This angle is more than 90 degrees, so it's obtuse. Now, we can do the same thing with triangles. These three angles, are they, look, here, let's do this one first. All right, here we go. This is telling us it has a right angle, this nice little square. So this is going to be a right triangle. See how easy that is. Now, these three angles, do they look greater than 90 degrees? No, they're all smaller, so this would be an acute triangle. And then this one, is this angle the same as 90, smaller than 90, or greater than 90? Like, wow, that would be greater than 90, so that would be an obtuse triangle. That's one way to classify triangles. The other way is by their sides. If you have a triangle that has three sides, well, all triangles have three sides, duh, but if all three sides are the same, then we call that an equilateral triangle. If two sides are the same and the third side is different, at least two sides are the same, third side is different, this is an isosceles triangle. If all three sides are different lengths, that would be called a scalene triangle. We can also use angles to help us determine which is the largest and which is the smaller sides. So what we do with that is, let's take a look at this example. Here's a triangle. It has two of the angles labeled for us, 61 and 60. Oh no, how am I going to know what that one is? Well, hello, we all know that the total degrees must be 180. Correct? If you don't know that by now, you need to start memorizing that. All right, so let's add those two. That would be 121. If we subtract that, look at that, we get 59 degrees. So this one is 59 degrees. Now, the side opposite 59 is this one right here. That would be the shortest side. Then we have the 60-degree angle. The side opposite the 60-degree angle would be the next smallest. And then, oh, look at that. We have a 61. The side opposite of that would be the longest. So if the book then said to you, all right, would you please list the sides from shortest to longest? Sure, we can do that. We're going to look opposite of 59, the smallest angle, pointing to YW. Put our little segment mark above that. The next smallest angle is 60, and that points us to Y. Did I just write YW? Oh, Mrs. Van Zalen, YX. Good grief. Getting old. Then we have YW. Then the largest angle is 61, and that's pointing over here. The side opposite is WX, right? WX. Ta-da! Okay, so except for my little goof right there, does all of that make sense to you? I hope it does. All right, let's say we have this beautiful triangle. And this beautiful triangle is giving us, oh, we have a 58-degree angle, a 61-degree angle. We don't know what Q is. Oh, no. What do? Yep. We take 180, add those two up, which would be 119, subtract it, and we would have a 1 and a 6. So this one is 61. What? Oh, look, they're the same. So let's see what that tells us about the side. The side opposite of angle R is SQ. The side opposite angle S is QR. That's a different measurement, so I'm going to put 2 tick marks. And then the side opposite another angle 61 is SR. So I'm going to put 1 so that they match. So now flip it around. We can tell we have 2 sides that are the same, 1 side that is shorter. Of course, we're pretending that I drew this all beautifully proportioned. So it would say, again, if we had to tell the book, all right, which side is the shortest side? Well, which side is opposite the littlest angle? That would be QR. We put a little segment line over that. All right, so far we're so good. We have acute triangles, right triangles, obtuse triangles, also known, we can say by their sides, equilateral, isosceles, and scalene. All right, so far so good. We're going to do the practice together so that you really, really get it, because I want you to get it. All right, so look in your book. If you're not already there, it's page 443. And we're going to do the practice. And all the practice is asking us to do is name these triangles. The first 3 we're going to name by the angles. So this one right here, ding, 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 it's telling us what it is. It is a right triangle. And yes, I know my drawing is opposite of the book. B, oh my goodness, what kind of angle is that? It's bigger than the 90, so that's an obtuse triangle. And then this one, itty bitty angles, right? They're not 90. They're less than 90, so this is an acute triangle. Now, if we have to describe them by sides, the book is going to give us these beautiful triangles, and they're going to tell us the side measurements. Here we have a triangle that has all 3 sides different. So what do we remember that is? It is a scalene. All 3 sides are different. Oh, here's 3 sides are all the same. What is that? You're going to remember the word equal, but it's actually spelled equilateral. It's an equilateral triangle. Here we have 2 sides that are the same, and only 1 side is different, so that is what? Yupper, the one that's hard to spell, isosceles triangle. Okay? Now, G, it gives us this beautiful triangle, and it tells us the sides. We have 2 sides here that are labeled. And it's telling us that it's an isosceles. That's very important, because what does isosceles mean? It means 2 sides have to be equal. Right? 2 sides have to be equal. Here we have a 3 and we have a 4. So this one, this third side could be a 3 or it could be a 4. Ha! It's telling us the perimeter does not equal 10. Well, if I put a 3 here, 3 plus 3 would be 6 plus 4 would be 10. So it cannot be 3. Therefore, it must be 4 centimeters. If it is 4 centimeters, which it must be, let's add up. What would our total perimeter be? It would be 4 plus 3 is 7, plus 4 is 11 centimeters. Is 11 centimeters not 10? Well, of course. So did we do that correctly? Of course we did. We're geniuses. All right. Not last one, but H. It gives you the triangle. It gives you all the angles. And it wants you to give this triangle both names. What? What are you talking about, both names? I want you to name it what kind of angles it has and then what kind of sides it has. Well, let's look at the angles. Are any of those 90 degrees? Nope. Are any of those more than 90 degrees? Nope. So what kind of triangle would it be by angle classification? It would be an acute triangle. Now it's going to ask us to look at the sides. Well, it's hard to say in this drawing, but remember, we can tell how long the sides are by the angles, right? And since we have all three different angles, we're going to have three different lengths. If we have three different lengths, what's it going to be? Scalene. That's right. Scalene triangle. Now, the last one in practice, I. Now it's giving us a triangle and it's telling us the sides, but it's not telling us any of the angles. But it's going to ask us, okay, please list from the smallest to the largest angle. What? Oh, I can't do it. Yes, you can, because the larger the side, the larger the angle opposite. So 21 millimeters, that means M is going to be the largest. So you know what I'm going to do? I'm going to put angle M right here. I'm going to put my comma before it because I'm going to work backwards. Then I have 20. 20 is the next largest, and that is opposite of angle N. So I'm going to put angle N. And then that means my little itty bitty baby one is opposite angle L. So I'm going to have angle L. So that would be the answer to that. What I want you to do for your pretend homework that we're going to finish in class, I want you to do all of these. So we got 1, 4, 5, 6, 7, 8, 9, 12, 13, 14, 15, 16, 17, 20, 24, 26, 28, and 29. Please get some of these finished there at home, and then we'll do the rest of them in class. I want to give you one hint because it's a little bit tricky. The first question, okay, hold on a minute. The first question says, at 1:30, Mrs. Kwan found a parking meter that still had 10 minutes until it expired. She put 2 quarters into the meter and went to her meeting. If 10 cents buys 15 minutes parking time, at what time will the meter expire? Oh my goodness, there are so many numbers and times in there. Whatever am I going to do? Well, you're just going to take it easy, calm down, and we're going to do it step by step. The only way to do math is step by step. So the first thing we're going to do is we are going to say to ourselves, all right, if 10 minutes or 10 cents buys 15 minutes, how many 10 cents are there in 2 quarters? Well, 2 quarters equals 50 cents. How many 10 cents? Divide that by 10, you get what? 5. So I have 5 chunks of 15 minutes. Okay, 5 chunks of 15 minutes. Well, how many minutes is that total? 15 minutes times 5 is going to be 75 minutes, right? So 75 minutes. If I want to change that to hours and minutes, we would take 60 minutes away, right? Because we have 1 hour then, plus 15 minutes. All right? So 1 hour plus 15 minutes. So let's add 1 hour plus 15 minutes and see what we get. Oh, we get a 5, we get a 4, we get a 2. However, that's not our answer because if we remember, she had 10 minutes already on that parking meter that she kind of got for free. So let's add 10 minutes to this. We get a 5, we get a 5, we get 2:55 p.m. So what time does she have to make sure she's back in her car so she doesn't get a parking ticket? 2:55 p.m. Now I did that kind of quickly, so I want you to think about this and ask me about it if you don't understand it. All right? Because that was a little tricky, a little bit tricky. So do the best you can, ask me about it, and I will see you in class tomorrow. Good night.